Section 2.2, the multiplication property of equality. Last time we looked at the addition property of equality, which told us that we can add or subtract the same amount from both sides of an equation, and it will result in a series of equivalent equations. That is, when we add or subtract the same amount on both sides, the resulting equation has the same solution as the previous. Since I know that the equation at the bottom is equivalent to the equation at the top, and that x is 6 at the bottom, then x must have been 6 at the top. Now we're going to look at problems involving multiplication and division. Let's look first at the brown box in the middle of page 112. The multiplication property of equality. If A, B, and C represent real numbers where C is not 0, then the equations A equals B and C equals B are equivalent. She goes on to say what that means is that each side of an equation can be multiplied by the same non-zero real number without changing the solution set. You wouldn't multiply both sides of an equation by 0 because that would simply wipe out both sides of the equation. Consider the equation 2x equals 14. Now we know that the solution here is 7. Let's look at the mechanics of solving this equation. We know that we can multiply both sides of the equation by the same thing. I want this to be x equals, in other words, 1x. How can I change a 2x into a 1x? I can take half of it. So multiplying, if I multiply both sides by 1/2, half of 2 is 1. In other words, those are reciprocals, and so they cancel. They give me the multiplicative nothing. 1x, or simply x, and half of 14 is 7. Multiplying both sides of an equation by 1/2 is the same as dividing both sides by 2. So just as in the previous section we could extend the addition property to cover subtraction, here we can extend the multiplication property to cover division. Brown box, top of page 113. Multiplication property of equality extended to division. It says we can divide each side of an equation by the same what? Non-zero number without changing the solution. You can't divide by 0. Division by 0 is undefined. She goes on to say, do not, however, divide each side by a variable because the variable itself might be equal to 0. So we don't divide both sides of an equation by a variable. And in both of these brown boxes, it said we want to use a non-zero number. This is not going to be too much of an issue right now. But there will come a day in chapter 6 where we will come back to page 112 and be reminded that as we multiply or divide each side of an equation, it must be by a non-zero number. So, extending multiplication property to division, I can say, well, what's happening to the x that's keeping it from being by itself? It's being multiplied by 2. What undoes multiplication? Division. So divide both sides by 2. The 2's cancel to leave x. And 14 over 2 is 7. So that's the gist of the section. Let's work some homework problems. Let me start with number 26. We want to get x by itself. We now know that we're allowed to not only add and subtract on both sides, but we can multiply or divide both sides by the same non-zero number. So long as we keep the equation balanced, we're in business. What keeps this x from being by itself? It's being multiplied by 5. How do I undo that? Divide by 5, both sides. And this will give me x equals, watch your signs, negative 12. As with any equation, we can always plug back in and verify that the solution that we came up with does indeed make the original statement true. Let's look at number 34. And I'll look at number 34 for a particular reason. I don't know why, but students often have fits with this type of equation. And I don't know why. What's preventing the x from being by itself? It's being multiplied by 7. How do we undo that? Divide by 7. Divide both sides by 7, and that's going to give me x equals, and I have gotten some crazy answers before. But ever since we learned division, we've known that what? 0 divided by, well, anything. 0 divided by 7 is simply 0. Like I said, I don't know why this gives students fits. It's a very simple equation. It's equivalent mechanically to the one that we just worked. But that 0 trips us up for some reason. As long as we're not dividing by 0, as long as 0 is not in the denominator, we're good to go. Plug that 0 back into the original. Is it true that 7 times 0 equals 0? Sure. Number 36. Now this is the one I was waiting to get to since the last section. Last time I said it is important, at least for this section, to collect our variable on the side where we will have a positive coefficient on that variable. Take your variables to the side where there were more of them to begin with. After we look at this, that will no longer be an issue. What prevents that t from being by itself? Well, it has a coefficient on it. What is the coefficient? What is multiplying that t? A negative 1. We don't see the 1 unless we write it. But it's being multiplied by a negative 1. How do we undo that? Divide both sides by negative 1. That will give me t equals negative 14. Plug that back into the original. Is it true that negative 14 equals positive 14? When we plug it back in, is it true that negative, and now we believe t is negative 14, is that equal to positive 14? And we know that two negatives make a positive in this instance. That's our double negative rule. And so sure, that checks. There are a couple other ways to interpret this problem. Let me return to the original problem. What we did there, we divided both sides by negative 1. We would get the same result if we were to multiply both sides by negative 1. Negative 1 times negative t, a negative times a negative is positive, 1 times t is just t, and equals a negative times a positive is negative, 1 times 14 is 14, same result. Or it is sufficient to say that if the opposite of t is positive 14, then t itself must have been negative 14. Nothing wrong with that. So divide both sides by negative 1, multiply both sides by negative 1, or simply take the opposite of both sides. Those are all equivalent steps. Now when we work problems, it doesn't matter which side we take our variable to, because if we end up with a negative coefficient on our variable, we know how to handle it. Number 40. We want to get x by itself. It's being multiplied by 0.9. So the most direct way to get x by itself, divide both sides by 0.9. On the left-hand side, the 0.9's cross-cancel to leave just x. On the right-hand side, we may need to go over to the scratch area and do a little work. Let's remember once again that to divide decimals, we set up the long division, the divisor into the dividend. We force the divisor to be a whole number by moving that decimal, in this case one place. We'll take the decimal that exists in the dividend, move it one place. We didn't have anything there, so we'll fill in a 0, and this predicts where my decimal will land in my answer. Now I can ignore the decimals in my long division and just say this is 9 into 180. 9 goes into 18 twice. 9 goes into 0, 0. No remainder, so there we are. X is going to be 20. Now, one thing you can do that is equivalent to moving that decimal in your long division problem is this. Let's go back to the original equation. Remember, the answer is 20. Because we can multiply both sides of an equation by the same thing, I can actually clear decimals from an equation. This is something we'll talk about again in the next section when it comes to fractions. But let's just take a look at this. If I don't want a decimal here on the left-hand side, what could I multiply by to force this 0.9 to become a whole number? If I want to move the decimal one place to the right, I multiply by 10. If I do that to both sides, then the equation is still balanced. I have an equivalent equation, and this gives me 10 times 0.9 is 9. 18 times 10 is 180. Isn't that the long division that we ended up with? So that's why it works. Now we can simply divide both sides by 9, and once again, find that x is 20. Either way you want to tackle that is fine. Let's have a look now at number 50. This time, our coefficient on our variable is a fraction. Now, I could say that the p is being multiplied by 1/5. And so I can divide both sides by 1/5. This is not the way I'm going to recommend that we do the problem. Remember that when you divide by a fraction, you flip and multiply. So this actually becomes 5 over 1, if you want to write it, times the 1/5 p equals the -3 times, flipping that fraction, we get 5, or 5 over 1. Here on the left-hand side, the 5's cancel to leave just 1p, or simply p. On the right-hand side, -3 times 5 is -15. Nothing wrong with that. But typically, when I see a fraction for my coefficient, I'm going to think more in terms of multiplying both sides, because that's generally easier. And in what I just erased, you see it's what we end up doing anyway. We end up multiplying both sides, in this case by 5. When I see a fraction coefficient on my variable, I'm going to think, well, the best way, the slickest way to get rid of that fraction is to multiply by its multiplicative inverse, by its reciprocal. 5 over 1. You can show the over 1 or not. Isn't this the same thing that we got simply by dividing and then using flip and multiply? So this is a little slicker. On the left-hand side, the 5's cancel once again. On the right-hand side, negative 3 times 5, negative 15. Now, in a problem like number 54, I'm going to treat this instead of as a fraction coefficient, although, please recognize this is the same as 1/8 times r on the left-hand side. So once again, this is mechanically equivalent to the previous problem, but I'm going to think about this one a little differently, just because it makes more sense to me this way. I'm going to say, what is keeping r from being alone? I want this to read r equals. What prevents that? It's being divided by 8. How do you undo division? You multiply. Multiply both sides by 8. If you want to see that 8 over 1, that's fine. On the right-hand side, the 8's cancel to leave just that r. On the right, negative 3 times positive 8, negative 24. Again, in this section, we're looking at the multiplication and division properties of equality, and we want to be sure that we use them to our advantage. Think about the problem, think about what needs to happen, and then approach it in a way that makes sense to you. Let's have a look at number 56. In number 56, I have a fraction coefficient. The slickest way to get rid of that fraction coefficient is to multiply both sides by the reciprocal. It's the same as dividing both sides by 3/8, because when you flip and multiply, you're going to be multiplying by 8/3 anyway. Multiply both sides by 8/3. On the left-hand side, the 8's cancel, the 3's cancel to leave just that x. On the right-hand side, you know that 9 belongs to the numerator. Show that over 1 if it helps. You know when we're multiplying fractions, we can cross-cancel. 3 goes into 9 3 times. And then finishing off, 3 times 8 is 24 over 1, but we do not write over 1 in a final answer. You can always plug this back in. Let's go ahead and check this one. Is it true that 3/8 times x, which we now believe is 24, is that equal to 9? Plug 24 back into the original equation. Put the 24 over 1, because you know that 24 belongs to the numerator. We can cross cancel. 8 goes into 24 3 times. And here on the left, 3 times 3 is 9. It would be 9 over 1, but that's simply 9. And so we have a true statement, which means that 24 must indeed be the solution. I want you to try one now. Let's have a go at number 60. Once we get it written down, go ahead and pause the video. Try this on your own. And when we come back, we'll compare answers. I will say this: watch your signs. I'm looking at an equation where the coefficient is a fraction. The coefficient on my variable, the variable I'm trying to get by itself, is a fraction. The slickest way to handle that is to multiply both sides by the reciprocal of that fraction. What is the reciprocal of negative 5/6? Remember, reciprocals have nothing to do with changing the sign. We're not taking the opposite, the additive inverse. We're taking the reciprocal, the multiplicative inverse. And so all we do is flip the fraction over. We leave the sign alone. Multiply both sides by negative 6/5. Strictly speaking, I should have parentheses to keep the multiplication and that negative from touching each other. But it's just our scratch work. I'm not going to get too worried about that. Here on the left-hand side, a negative times a negative is positive. The 6's cancel, the 5's cancel, and it leaves just positive 1x. We write simply x. On the right-hand side, we look for cross-canceling. I see a factor of 3 top and bottom. 3 goes into 6 twice. 3 goes into 9 3 times. That's all that will cross-cancel. So we have a positive times a negative is negative, and now multiply the tops, multiply the bottoms. Negative 8/15. And again, we can plug back in to make sure it gives me a true statement. This one, because of cross-canceling, actually would not be too bad to check by hand. Let's crank this up just a little bit. Throw another step into the mix. Look at number 64. And what did we learn last time? Before we start juggling things around, we want both sides of my equation to be simplified. All of our equations to this point, both sides have been simplified. But here, the expression on the left-hand side of this equation can be simplified further. And so we will carry out the subtraction combining like terms. 3p minus 7p, negative 4p. The right-hand side was already simplified. Now we know what to do. The p is being multiplied by negative 4. So we divide both sides by negative 4 to leave p equals negative 6. Number 68. This one would be a good one for you to try on your own. If you want to pause the video, give this a shot before you see me work it out. Help yourself. Go ahead and give that a try if you want. On the left-hand side, we need to simplify. All three of these are like terms. And so we have 9 of them plus 2 of them is 11. Minus 7 is 4. 4 what? 4r. When we combine like terms, 9r plus 2r is 11r. Minus 7r is 4r. We know now just divide both sides by positive 4, the coefficient on our variable. And that's going to leave me r equals 17. Let me tell you what just happened in my head. To divide by 4 is to cut a thing in half twice. If you cut something in half twice, you've divided by 4. So in my head, I'm thinking, well, half of 68 is 34, and half of that is 17. That was the quick way for me to divide 68 by 4. If that helps you, use it. If you'd rather do a long division over to the side, that's fine as well. Number 74. Mechanically, this is the same problem that we just worked. If you compare this to number 68, you will see exactly the same algebraic setup, except instead of integers this time, we have fractions. But we're going to work it the same way. Exactly the same way. We need to combine like terms here on the left-hand side. But when it comes to fractions, of course, we need a common denominator. Least common denominator for all three of these fractions is 20. So we need a factor of 4, top and bottom. We need a factor of 2 here, top and bottom. So let's rewrite this now as 4/20 x plus 2/20 x. And this one was already ready to go with the needed denominator, 1/20 x. And now combine like terms. Watch, we have what? 4 of them plus 2 more of them is 6 of them. Minus 1 leaves me 5 of them. Now let me go back and fix my mistake. 2 times 4 is not 4. Sorry about that, guys. That's dumb points, right? 2 times 4 is 4. No, it's not. Our goal is to minimize losing dumb points, right? Happens to everyone, me included. Let's try this again. We've got 8 of them, plus 2 of them. That's 10 of them. Minus 1 of them leaves 9 of them. 9 what? 9/20 x. The simplest thing to do when you have a fraction for a coefficient on your variable is to multiply both sides by the reciprocal of that coefficient. Multiply both sides here by 20/9. Would you like to see this 18/1? That's fine. You don't have to write that so long as you know that 18 belongs to the numerator of that product. Here on the left-hand side, the 20s will cancel, the 9s will cancel to leave just x. And of course, that's our goal. On the right-hand side, we can cross-cancel. 9 will go into 18 twice. And 2 times 20 is 40. I'm going to say again, this one would not be too tough to check. I recommend that you plug this 40 back into the original equation and see that you can perform that check. That 40 is going to cross-cancel nicely with each of those denominators, so it shouldn't be too messy. Strongly encourage you to plug that back in and make sure that you are able to perform that check. And then here toward the end of the homework, let's do a couple of these where we're translating English to algebra and solving these resulting equations. Let's look at number 80. Number 80 says, when a number is multiplied by -4, the result is 10. Find the number. Our instructions are to write the equation using x as a variable and then solve that equation. So now, a piece at a time. When a number is multiplied by -4. Okay. Now, strictly speaking, that would be a number times a -4. But in algebra, we almost always put our numeric factors in front of our variable factors. And we know that multiplication is commutative, so there's nothing wrong with saying that when a number is multiplied by -4, that's -4x. It says the result is, there's my equals, the result is 10. Find the number. So there's part of my answer. She wanted me to translate into an algebraic equation. We've done that. Now solve the equation. Divide both sides by -4. On the left, my -4's cancel to leave just x. On the right, now class, I've asked you to answer this a certain way. What is 10 divided by -4? It does not divide out evenly, so what am I responsible for doing? Reducing this fraction to lowest terms. Positive divided by a negative is negative. 10/4 reduces to 5/2. So when I ask you the question, what is 10 divided by -4? You'll say, oh, that's -5/2. That's all we're after there. Let's finish up with number 82. It says if twice a number is divided by 5, the result is 4. Find the number. Piece at a time. If twice a number, that's 2 times my number. If twice a number, that whole thing, is divided by 5, the result is 4. If twice a number is divided by 5, the result is 4. So we have our equation. Now we want to solve it. Do you recognize that this is equivalent? What is the coefficient on x? Let me ask it that way. What is the coefficient on this x? It's not 2. What is the number that's multiplying this x? To make this entire term, what number is multiplying that x? Isn't it that whole 2/5? That's the same as 2/5 times x, right? Not sure? Put this x over 1, multiply the tops, multiply the bottoms. Put you right back there. So, seeing that the coefficient on x is this fraction 2/5, the slickest way to do this is to multiply both sides by the reciprocal. Multiply both sides by 5/2. On the left-hand side, 2's cancel, 5's cancel to leave x. On the right-hand side, you need to see that 4 is over 1. And what's going to happen? I don't want to write up here because this is a final answer. She asked for the equation itself, so I don't want to mess with my answer. Can you cross cancel on the fly with me? 2 goes into 4 twice. I like just to say 4 divided by 2 is 2, times that 5 is 10. 2 goes into 4 twice, and 2 times 5 is 10. That's an easy one to check. You can check that one in your head. Plug 10 in for x. 2 times 10 is 20, and 20 over 5 is 4. That checks. In the next section, we're going to put it all together. There will be no new rules to look at in section 2.3, just bigger problems that have more steps. While we're here on this same page as the problem we just worked, you see we're going to have a blue box at the beginning of the section that will give us a general approach, a general attack for solving linear equations in one variable. And so that's where we'll start next time. So for now, off you go to do your homework, section 2.2.